All right, now the point we want to make is if you're solving the equation ax squared plus bx plus c equals 0, as long as the a is not 0 and the a, b, and the c are real numbers, we will basically get as our solution x equals negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. So whenever you apply the square root property by way of completing the square to ax squared plus bx plus c equals 0, and your a is not 0, your solution or solutions are going to take on this form. Now we call the expression that is the radicand, that's the expression underneath the radical, we call that b squared minus 4ac. That's called the discriminant. And we can find the number and type of solutions just by looking at the discriminant. And let's talk about that. So first of all, I can't find the discriminant until I have a 0 on one side of my equation. So here, I want to add 4 to both sides of the equation. And that will give me a 0 on one side of the equation. So this equation becomes x squared minus 10x plus 29 equals to 0. So a is the coefficient of x squared. That's an unwritten 1. B is the coefficient of x. That's negative 10. C is the constant in the problem. That's 29. So notice you can't determine your A, B, or C until you have 0 on one side of the equation, everything else simplified on the other side of the equation. So let's calculate D, which is the discriminant, which is b squared minus 4ac. So 29 squared minus b squared, which is the square of negative 10. B is negative 10. So the square of negative 10 minus 4 times 1 times 29. Is 100 minus 126. I'm sorry, 116. That's what I meant to say, 116. So this is negative 16. So whenever the discriminant is less than 0, which means it's negative, there are always two imaginary solutions. And these solutions are complex conjugates of each other. So we have two imaginary solutions. And we can go ahead and find the solutions. Remember, x is minus b, so that's minus 10. Plus or minus the square root of my discriminant, which is the square root of negative 16, over 2 times whatever my a is. So this is 10 plus or minus, the square root of 16 is 4. The square root of negative 1 is I. plus or minus 4i divided by 2. 10 divided by 2 is 5. 4i divided by 2 is 2i. So those are my solutions, 5 minus 2i and 5 plus 2i. Okay, so here I have another equation that I want to solve. And x squared minus 7 equals 3x. So I want, when I use the quadratic formula, which is what I get here, this is called the quadratic formula. And you do need to know that by heart. I need to have a 0 on one side of the equal. So I need to subtract 3x from both sides of this equation. Then once I have a 0 on one side of the equation, everything else simplified on the other side, I can get my a, b, or c. My a is 1, my b is negative 3, my c is negative 7. So the discriminant, which we call d, is b squared minus 4ac. So that's the square of negative 3 minus 4 times 1 times negative 7 equals 9. Negative 3 times negative 3 is 9. Minus 4 times 1, which is negative 4, times negative 7, plus 28. So that double negative becomes a positive. So this equals 37. All right, so that's a positive number. So whenever the discriminant is positive, there are two unequal real solutions. These are real solutions, are solutions that are a real number. So there are two unequal real solutions. So remember our D was 37. So we are going to plug that discriminant in so we can find the solutions. Minus b is minus minus 3. Plus or minus the square root of b squared. That's the square of negative 3. Minus 4 times a, which was 1, times c, which is 37. And this is all over 2 times a, and a is 1. So this is 3 plus or minus the square root of 9 minus 148. That's all over 2. So this is 3 plus or minus the square root of negative 139 divided by 2. Okay, so 139 doesn't have any factors that are perfect squares. So we can't simplify the square root of 139. So we write this as 3 plus or minus square root of negative 1 times the square root of 139 all over 2. So this is 3 plus or minus I times the square root of 139 all over 2. And it's good form. So this is what our x equals. And it is good form to give the 3/2, to put the 2 under the 3, and to separately put the 2 under the I times the square root of 139 over 2. Okay, so those are my solutions. And we said there would be two oh my goodness. Okay, so our D is 37. So X is minus B, and our B is a -3, plus or minus the square root of D, which is 37, all over 2 times A. So this is 3 plus or minus the square root of 37 over 2. These are what my solutions are. And we can leave that like that. And when you go to fill in the solution set, you're going to get 3 minus the square root of 37 over 2. That's one solution. And the other solution is 3 plus the square root of 37 over 2. And these are two unequal real numbers that happen to be irrational. And so we can approximate these, but the only way we can give an exact value is to leave these in this form. Otherwise, if we try to write them as decimals, we can only write an approximation. All right, so here we have this already set equal to 0. So we're able to get our A, which is 1, our B, which is 6, our C, which is 9, right off the bat. So our discriminant is B squared, 6 squared, minus 4 times A times C, which turns out to be 36 minus 36, which is 0. So whenever the discriminant is 0, there is one real solution. And a lot of times this is called a repeated solution. If you were to factor x squared plus 6x plus 9, you would get x times x plus 3 times x plus 3. So you get a repeated factor. When you set those two identical factors equal to 0, you get whatever your solution is twice. So x is minus b, which is minus 6, plus or minus the square root of d. Remember, d was 0, so that's plus or minus the square root of 0 over 2a, 2 times 1. So this is minus 6 plus or minus 0. The square root of 0 is 0 over 2. So this is minus 6 over 2, which is minus 3. So your solution set has this one real number in it, and that real number is -3. So that's my solution set.